In the last video, I have explained that Liskov substitution principle states that the is-a relationship is insufficient and it should be replaced with is substitutable for, right? So let us try to understand what is the limitation we face while using a is-a relationship in this video, practically using the demo. Let me first create a new file with the name isa_limitations.py and let me provide some room space for the coding. Now let us start with our coding first. I would like to define a class with the name rectangle. So let me type in class rectangle colon. We know that every rectangle will have height and width. So let us define a constructor to initialize the values for the rectangle width and height. So let me type in def thunder init of self comma width equal to 0, height equal to 0 colon, self dot underscore width equal to width and self dot height equal to height. Now let us define some setter and getter methods for the width and height variables. So let me type in def get underscore width of self colon, return self dot width and def set underscore width of self comma value colon, self dot underscore width equal to value. And similarly for the height we need to type in def get underscore height of self colon, return self dot underscore height and set underscore height of self comma value colon, self dot underscore height equal to value. Now let us define the properties for width and height. So let me type in width equal to property of get underscore width comma set underscore width and height equal to property of get underscore height comma set underscore height. Once we have defined the class rectangle as per our requirements, we need a area calculator class to perform the area calculations. So let me type in def calculate area of self comma rectangles colon. For rectangle in rectangles colon, print of format area colon rectangle dot width times rectangle dot height. Let us define one more class with the name square, and we know that as per geometry square is a rectangle, right? So it perfectly matches the is-a relationship, which means inheritance. So let me type in class square of inherits rectangle colon. Since the width and height variables are inherited from the rectangle base class, let us update only the width and height properties of the square class. Because if a shape has to be considered as a square means width and height should always remain same, right? So for that let me define def get underscore width of self colon, return self dot underscore width and def set underscore width of self comma value colon. That is, if the user sets only the value for the width, then I would like to automatically change the height value also to have the same value. So let me type in self dot underscore width equal to value and self dot underscore height equal to value. Similarly for the height property also let us do the same. So let me type in def get underscore height of self colon, return self dot underscore height and then def set underscore height of self comma value colon, self dot underscore height equal to value. If the user changes only the height, then I wanted to automatically change the width of the square. So let me type in self underscore width equal to value. Now let us update our properties. Width equal to property of get underscore width comma set underscore width and height equal to property of get underscore height comma set underscore height. Once we have defined these two classes, let us define the objects for the class. So let me type in sq equal to square and sq dot width equal to 10. And for the code readability, let me set the value for the height also. Sq dot height equal to 10. Next, let me define one more instance. In other languages like C#, we might type in something like rectangle rect equal to new square. But since we don't have that support in Python, we need to directly type in rect equal to square. And let me set the values for the width and height. So let me type in rect dot width equal to 10 and rect dot height equal to 5. Now let us define a list of shapes. So let me type in shape equal to list of square comma rectangle, and then let me define an instance for the area calculator. So let me type in AC equal to area calculator and AC dot calculate area of, let me pass the list of shapes. Now let me save the code and execute the program. We can observe for the first one we got the result as 100, and for the second rectangle object we got the result as 25. What could be the reason means, since I have mentioned rect.height equal to 5, so this statement will try to set the height property, and we know that whenever either height or width has been set for the square, automatically the same value will be set for both width and height, right? So 5 times 5 will become 25. Now if you observe the is a relationship, square is a rectangle, but we can clearly observe the limitation what we have in these two shapes, right?